Okay, welcome back, Earth Science 11. So this video is hopefully going to be fairly brief. Just wanted to give you a bit of information. We're going to be going into the topic of precipitation for the week, and there's a little bit of background information that you're going to need before you can really dive right in. And hopefully the activity that we're going to do this week, hopefully you'll find it interesting. If you look on OneNote or on Google Classroom, you'll have both of these documents here and here attached. This one and this one both be attached, and so you'll be able to download these and fill them out for yourself. This first page here is all we're going to fill out for notes today as a class, and then these other stations 1, 2, 3, and 4, these will be your activities that you'll need to get the information from this document here, the precipitation station information. Okay, so the first thing that we need to fill out or to figure out is the phase changes. So a phase of matter is essentially solid, liquid, or gas. There's some other ones in there, but we'll stick with the basics for now. And so between these three, if you can take a minute or two and just pause the video and try and fill in these phase changes. So what we're saying, for example, is the state or the change when you go from a solid to a liquid. What do we call that phase change? So hopefully you know this one here would be melting. Sorry, let me spell that correctly. Melting. That's going to be our first phase change. And what I'd like you to do is try and label all of these other phase changes. So what do we call it? Gas to liquid, liquid to gas, solid to gas, gas to solid. So I'll give you a minute, pause the video, and try and fill out these other 5 phase changes. Okay, hopefully you're finished. Hopefully you did pause it. Hopefully you did fill in the information there. And so just in case there's anything missing here, let's go over it. So we have solid to liquid, that is melting. When we go from liquid to solid, that would be, of course, freezing. When we go from a gas to a liquid, this is going to be condensing. And going from a liquid to a gas, this could be one of two things. So it could be evaporation. Now, evaporation can happen at any temperature that's below the boiling point. So for example, if you have a puddle on the ground and you were to watch it slowly, watch it evaporating very slowly, it would eventually evaporate. Or you could just come back the next day and see that that puddle has gotten smaller and smaller. So that's evaporation. It's when the liquid that's on the surface can leave the surface and go up into the atmosphere as water vapor. It doesn't have to be boiling temperature in order to evaporate. It can happen at any temperature. And likewise, there is also boiling. And this is when it's at the boiling point. So for water, for example, that would be at 100 degrees Celsius. Likewise, this melting and freezing happens at 0 degrees Celsius. So it freezes when it goes below 0, or it melts when it goes above 0. Boiling happens at 100. Now this one here is probably the one that's least familiar to us. So there's a term called sublimation. Sublimation can be used for both ways. So if you have solid going to a gas, you can call that sublimation. And gas going to a solid, that can also be called sublimation, which is odd that it's the opposite thing, but for both of those processes or those phase changes, you can use the word sublimation. There are other terms that are acceptable, but we'll just stick to those for now. Okay, so this should be very familiar with us from previous years of high school. Now, going on to relative humidity. So relative humidity is something that you'll need to know in terms of learning about precipitation, which is this week's topic, or to do with cloud formation, which is next week's topic. Okay, so this may be a new term for you. This is the term called relative humidity. And relative humidity, what that is, it's the total amount of water vapor. So that's going to be water in the form of a gas. So it's the total amount of water vapor in the air compared to the amount it could hold. So let's say we have a beaker here, and in this beaker, it's a very small beaker, there's only enough room to hold 8 water molecules. That's the maximum number of water molecules that you could fit in this beaker here. Now let's say there are only 4 water molecules in this beaker. So let's fill these up. So let's say we've got this water molecule, this water molecule, this water molecule, and this water molecule. So we have 4 water molecules in the beaker. The most that this beaker could have possibly held was 8. And so how can we figure out the relative humidity? Well, it's just a percentage. So in this case here, we can do this as a fraction or a percent. It's 4 water molecules out of a maximum of 8 water molecules. And this is the same, if you put this into your calculator, you'll see this is 0.5. So if we want to turn this into a percentage, because relative humidity is always listed as a percent, or as a percentage, and so 0.5, you just take this, you multiply by 100%, and this gives you 50%. So the relative humidity in this case here, for this particular beaker, would be 50%. That's the amount that it's holding compared to the total amount that it could hold. Now another term you'll need is saturation. So saturation is essentially where you're going to have 100% relative humidity. You've got all the water molecules that you possibly could have. So you're holding the maximum water vapor capacity. You couldn't possibly fit one more water molecule in there. So when it is warm, the air can carry more water vapor. And so, in essence, this is actually a bit of a mistake here. Let me just correct this here. So, another way of thinking about this is, imagine that you have a sponge. Now, if you have a sponge that's fully kind of inflated, let's say you have a sponge, you haven't squeezed it, it's just lying in the sink, and you've absorbed as much water as you possibly can. So, a sponge, when it's not being compressed in any way, shape, or form, that would be like air that's warm. And now you can imagine that if you have that sponge and it's just lying there, it's not being squished or squeezed in any way, it can hold a lot of water. So that would be like warm. Warm air. So in the case of warm air, we would have, let's say, a maximum of 8 molecules of water. And if it was saturated, we would have all 8 of these being filled up. So we'd have 100% relative humidity. You'd have maximum of 8 out of 8, and so that would be equal to 1, which you multiply by 100%, and you're going to have 100% relative humidity. So that's what we call saturation, is 100% relative humidity. Now, a warm body of air is like a sponge that's not being squeezed. Now, when the air cools down, you can think of that like a sponge that's being squeezed. And so if you cool air down, it would be, another way of thinking about that would be taking this beaker and shrinking it down. So this beaker right now can hold 8 water molecules, and you've got all 8 in there. If you cool this down, it would be like making this beaker small. So what do you think is going to happen if we were to suddenly make this beaker a lot smaller? Well, right now it's saturated. It's got 100% of the water molecules that it can have. It can fit 8, and we have 8. Well, suddenly we go ahead and we make this air cooler. So you can think of that again like squishing a sponge, or maybe making this beaker smaller. Well, you can only hold 6. So what do you think is going to happen to these other 2 water molecules here? Well, those would form precipitation. So this is what happens in the air. As we take warm air that's full of liquid, as we lift it up higher and higher, we saw from our previous lessons that as air lifts up, it gets cooler, and we know that cooler air is going to be able to hold less water, and so essentially you can kind of think of it as the water falls out of the air. You can't hold that much water anymore, and so it's got to go somewhere. It forms these solid drops. You can't have any air as a gas, so that air will have to kind of form as a liquid. And so when you have warm air, you can still have, if you warm up air, let's say I were to make this warm again, so let's say I can now hold 10 molecules and I've only got 8 in there, this would mean that I have a lower relative humidity, because now with my new warmer air, I'm able to hold 10, I only have 8 at the time, and so it's going to be a lower relative humidity. So this will, if you heat up air, you will reduce the relative humidity, because you may have had 8 out of 8, but now you have 8 out of 10. The air is warmer, it could hold more, so you're going to reduce that percentage. It was 100%. When you reduce it to, say, for example, 8 out of 10, the relative humidity becomes 80%. Now, when it's cool, the air is able to carry less water molecules. So again, that's like going back to our example. Let's say I have 8 out of 8 air molecules. Well, when I cool it down, I'm going to shrink the size of the beaker. We can only hold 6, so these extra 2 are going to fall out. It's still going to have, it's going to end up having a higher relative humidity. So cooling air will increase the relative humidity. So that's what happens when you cool air. It's not able to hold as much water anymore, and that's going to make it a higher percentage. So another example is if we started with 4 out of 6, but then we cooled it down a little bit and we're only able to hold 5, we would now have 4 out of 5. So we had this fraction, 4 out of 6, and now we have 4 out of 5. So our relative humidity, our percentage, has gone up. So 4 out of 6 is going to be a relative humidity of 66%, and 4 out of 5 is going to be a relative humidity of 80%. So we can see here by cooling the air down, we're going to reduce this number here. It was able to hold 6, now it's only able to hold 5, and so we can therefore see that our relative humidity is going to increase. So that's what you need to know about this topic so far. That should be enough information to get you started. So your homework due for Friday is going to be this right here. And if we take a look at our plans for Earth Science 11 for the week, this is what we had for you. So plan number 1 is watch this video. That was just a brief video about precipitation. Then hopefully you've already watched my welcome back video. Then you're going to download this sheet and the worksheet, and like we said at the beginning of this video, they're going to be on Google Classroom, well now if you're seeing this video obviously, and you're going to complete the rest of the student notes worksheet. So that's the 4 different stations, and your homework, this is what how I'm essentially checking to make sure that you're staying engaged with the learning, is going to be writing 2 to 3 sentences about one of these stations. So there's 4 stations to choose from. Choose one of them and write 2 to 3 sentences as a summary. And this is my way of ensuring that you are staying engaged with the learning and still participating. So thank you very much for watching, and if you have any questions, please email me right away. Please email me before Friday if possible, and best of luck with this. Thank you.